Hey, what's up? It's me, Mr. Cho. I'm currently sick, so I can't come to school, but I'll try my best to teach you from home. So I'll like everybody to take out their textbook and turn to page 80. I give you 10 seconds for that. Okay, so I think you should have your textbook out, page 80. Now let's talk about this chapter. This chapter is about separation techniques. So when we say separation, we mean how do we take apart two things, right? For example, I have sand and water. I want to remove the sand from the water. How do I do that? Right. So there are 5 different techniques that we'll learn in this chapter, and we'll go through them one by one. Okay, let's talk about food that we eat. So every day we eat food, and there's a lot of waste that we discard. And sometimes we just throw all the things into the rubbish bin, but actually there's actually a better way to do things where we can actually separate the mixture into the correct bins, right? So we can reduce, reuse, and recycle for sustainable living. Okay, we know that we need water to survive, right? Water is important for all living creatures, and globally, right, actually millions of people, they don't have access to clean water, so they actually drink dirty water. And this is made even worse by climate change because the weather gets more erratic. There's droughts in certain countries, and so there's these new technologies that are needed to to separate the water more efficiently. Okay, so how do we choose the appropriate separation techniques? Okay, so we see that in many industries, they make use of these separation techniques so that they can get good products and for their services. Right, so one example would be in waste management. Okay, now this is a landfill. A landfill or a dump is where you kind of like throw away all the old furniture, old chairs, old tables, even old cars, right? That's called a junkyard. Right? So all these old parts, right, they are broken down, and then they are extracted, right? They are separated using certain techniques. As we can see here, this crane is actually holding on to a electromagnet. Okay, so this electromagnet is quite interesting. It's able, when you turn on the switch, right, electrical current flows through, so it flows through the cables into the magnet, and this will cause this block over here to become magnetic. And when this is magnetic, then the metallic objects, right? Some metallic objects, they contain things like iron, nickel, cobalt, right? These are the 3 commonly found magnetic metals. Okay, so not all metals are magnetic, but these 3, iron, cobalt, and nickel, they are actually magnetic, and so then they will be attracted to the electromagnet. Then what can the people do with this, right? They can actually resell it. They can resell this stuff, the iron, all that. They can turn it to steel, right? And then use it for other purposes. Okay, so that's called recycling. So we also see in some countries, right, they actually use evaporation. What is evaporation? Is basically when you use the heat energy, right, whether it's from the sun or from a heat source like a Bunsen burner, you use the heat energy and then you evaporate away the water molecules that are found in the object. So for example, a fish has some water, you evaporate all this water and it becomes dried ikan bilis. Another technique that we know about is called chromatography. And chromatography is a technique used to separate a few soluble solvents. Okay, so we have things like dye. For example, dye, we have black dye. When you see black dye, it's actually not black per se, right? Actually, black contains a few other colors. For example, a black dye could be red, green, and blue dye to mix together to get black. So if you want to actually see what is inside this dye molecule, you actually have to use this thing called chromatography to separate it. In Singapore, we also do this thing called filtration and reverse osmosis. Okay, we'll learn about filtration. We won't really talk too much about reverse osmosis, but basically filtration is quite a simple concept. Like when you do cooking, you have that sieve, right? You pour your water through the sieve, and then the big molecules, they are not able to go through the sieve. Okay, the reverse osmosis is a bit more complicated. We'll talk about it when it comes. Okay, so let's start by talking about how we can separate a mixture of magnetic and non-magnetic substances. Okay, so what are some magnetic substances? I would like you to write this down. Now, many of us have this assumption that all metals are going to be magnetic, but that's not true. Okay, so only iron, cobalt, nickel. These are elements that are let me rewrite that. These are magnetic elements. Okay, so iron, cobalt, nickel, if you want to take a look, you can actually find them on the periodic table. Okay, they're over here. Iron 26, cobalt 27, and nickel 28. These are the naturally occurring magnetic elements. Oops, sorry, what did I do? Sorry, I went into some funny mode here. Okay, try this different way. Okay, we're back. Okay, so besides that, we also have some compounds. Remember we learned in the previous chapter about compounds. We see that compounds are some magnetic. So usually any compound that contains iron, right? Compounds with iron can be magnetic, and mixtures with these elements I just mentioned. Right, so one example of a mixture which contains iron and is magnetic is steel. Remember we said that steel is actually a mixture of carbon, iron, and some other elements. Right, so steel is a mixture, is what we call as an alloy, right, and it's actually magnetic. Okay, so let's look at this statement over here. Magnetic substances such as iron and steel are attracted to a magnet. Steel is a mixture of iron and other elements. Other substances such as plastic and paper are non-magnetic. Thus, we can use a magnet to separate magnetic substances from non-magnetic substances. For example, when a magnet is placed near a mixture of iron filings and sulfur, only iron filings are attracted to the magnet. Sulfur, which is non-magnetic, is left behind. Okay, so here we have a very simple experiment. We see that we have a plate with a mixture of iron filings. Okay, what are filings? Filings are like shave, like shave ice, right? You shave very finely. You have an iron bar, you just like shave, and then it becomes these iron filings. Okay, then you have the sulfur. Now, sulfur is also an element. You can find it over here, right? This element here, number 16, sulfur. Okay, so what do we expect to see? I think this is something that we all can understand, but let's just watch the video anyway.
In this experiment, we will learn about the differences in properties between elements, compounds, and mixtures. Two elements, sulfur and iron, are mixed together, resulting in a grey mixture.
Okay, so at this point, you see here, right, we have iron filing with sulfur. Is this a compound or is it a mixture? Right, obviously we know that it's a mixture because these two elements are not chemically combined, right? There's no reaction between them, and so nothing really happens, right? They are just mixed together, but they have their own properties. They keep their own properties.
Magnet is brought near the mixture. It attracts the iron filings, leaving behind sulfur.
Okay, now make a smart guess. Why did they wrap this magnet with a plastic bag? Like, why did they put a plastic around the magnet? Okay, make a guess. Tell your shoulder partner. Okay, you are right. So actually it's just easier to remove the iron filings. If not, imagine you have to scrape it off. It will take a long time. So it's just easier to use a plastic bag and it's more convenient.
As you can see, a mixture of substances can be easily separated via physical means, such as by using a magnet.
Okay, let's continue with the rest of the video. So in this part of the video, they will show you what happens if you chemically react the iron and the sulfur together. Okay, so remember that when you mix the iron and sulfur together, they are just a mixture. There's no reaction. But what will happen if you go and heat it up? Let's see what happens.
Now, let's heat up the same mixture in a test tube and see what happens.
Okay, so you see a chemical
As the
reaction.
heating continues,
It's a chemical reaction
iron
occurring.
and sulfur begin to react with each other, causing the mixture to glow. When the Bunsen flame is removed, the reaction continues and gives out a lot of energy. The grey-black brittle solid formed is a new compound, iron 2 sulfide. Unlike a mixture, its constituent elements, sulfur and iron, cannot be separated via physical means.
Okay, so we see here, right, this is iron sulfide, but this is not able to be attracted to the magnet because this compound, remember we learned about compounds, they do not have the same properties as their constituent elements. So even though iron, it could be attracted by itself as an element to the magnet, and sulfur does not, right? In this case, when it's a compound, this sulfur dioxide compound, it does not get attracted to the magnet. It's a non-magnetic compound. Okay, so we have learned about this is called the magnetic separation. Now, do you think that this is a physical or chemical method of separation? What do you think? Okay, this is actually a physical method of separation. I spelled wrongly. Okay, so when I say physical, it means that it's usually reversible. You can always undo this method, and it's quite easy to do, right? It's an easy method to do. Okay, so what other uses of this metal separation can you think of? Okay, I don't know if you all watched Toy Story. I think there's this part, right? Toy Story magnet. Okay, there's this part where they are on the like a conveyor belt lah, and so the toys were about to be crushed. Okay, I'll just show you this scene.
Woody, what do we do? We'll be okay if we stay together. Woody! Slinky! It's a magnet! Watch out! Ah! Don't worry, Slink. We'll get you down. I won't take a lift. Quick, grab something metal. Help me! I'm stuck! Help, please! Help! Buddy! Thank you! Don't thank me yet! Woody!
Okay, making use of a lever. Alright, so that's a very smart use of magnets, right? Magnetic separation, where they are able to actually escape from their danger, right? Because they are able to use the power of science, right? The idea of science to actually solve their problem. Okay, now let's go back. Okay, so some other applications of magnetic attraction. here we can see scrap metal. In Singapore, scrap metal is one of the many waste materials that are generated. Scrap metal contains a mixture of metals such as aluminium, copper, and iron. Okay, as we mentioned just now, not all metals are going to be magnetic. So copper and aluminium, these are non-magnetic metals. And then only iron, which is magnetic, can be removed from the mixture by passing a strong magnet over, and then we can reuse and recycle this iron. Okay, what can we use it for? Iron bar, iron chain, steel. As we said, steel is a alloy of iron and carbon, and then you can make these steel bolts, etc. Okay, what can we use for the non-magnetic material that are left behind? Things like glass, things like rubber, right? And they can be converted back into tires or plastic parts, right, of the car, and it can be recycled. Okay, hold on a while. Okay, so separation of a mixture with different particle sizes. Okay, so when I say different particle sizes, it means that one part of the mixture is maybe very big and one of the mixture is very small. Okay, very small. That's very small. Okay, so how do we do this? All right, we see that substances with different particle sizes can be separated using a sieve. Okay, a sieve has small holes called pores, which are of a particular size. Particles that are smaller than the pores pass through the sieve. Particles that are bigger than the pores are retained by the sieve. Right? This separation technique is called filtration. Okay, now in case you don't know what is a sieve, let's just do a quick search here. Okay, so this is a typical kitchen sieve, right? Something where you pour, you can put your flour through or sugar or something. Only the small substances can pass through. The big things will be left behind on top. Okay, so that's a sieve. So this method is called filtration. All right, please take a highlighter and highlight this word filtration. Okay, so let's look at the steps for filtration. Okay, firstly, I pour a mixture of chalk and water into a filter funnel that is lined with filter paper. The filter paper acts as a sieve. Okay, so we see that the chalk, right, is insoluble in water. Let's write it down. Insoluble, right? It's insoluble chalk, and so it just stirs around. You can see that in the mixture of chalk and water, when you pour it through, the pores of the filter paper will allow the water particle to pass through them. Right? That is because water is a very small particle. Right? So it's water particles are very small. They can pass through the pores of the filter paper. Okay, whereas the chalk particles, which are bigger than the pores, are retained by the filter paper. Okay, now I realize that maybe some of you also have never seen filter paper, so let's show you what filter paper looks like. Okay, so filter paper looks like this. It's just a thin piece of paper. And you can look very closely, you can see that there are actually very tiny holes inside this filter paper. Okay, so that's how it is. Okay, we see that the chalk particles, they are actually trapped, right, by the pores. They cannot pass through the pores in the filter paper. So we call these chalk particles, that this solid that are left behind on the filter paper, we call them as a residue. Please highlight. Whereas the liquid that passes through the filter paper is called the filtrates. Okay, so this water below, right over here, this will be called the filtrate. Anything that is trapped by the filter paper, we call that as the residue. Okay, so filtration is a process of separating substances of different particle sizes using a sieve. Right, so one of the very simple and efficient methods, and doesn't really cost much. Right, you just use a filter paper or a filter sieve, then it's enough already. Okay, let's look at some examples of filtration in our life before we watch a video. You see that filtration is important in our daily lives because you can use it to make tea. Right, so for example, when you make tea, there's this thing called a tea strainer. Right, the strainer is just this metal object here. It's like a sieve like that. And these tea leaves, as they remain the tea strainer, the tea molecules, right, the tea particles, it can dissolve from the tea leaves, and then it enters into the water. And that creates the tea drink that we are drinking. Okay, so the tea leaves are the residue, whereas the tea solution is the filtrates. Right, the tea filtration, the solution is able to go out of the filter over here. Okay, please write this down. Tea leaves are the residue, tea solution is the filtrate. Give you 20 seconds to do so. Okay, let's move on. Okay, one other example would be when we want to have a well. Okay, so let's say you want to have clean water, right? Like something like a well. We can actually use the properties, right, of the filtration to get clean water. How do we do that? Right, we basically use sand and rocks, right? We know that we cannot drink water that is muddy, right? So actually we use rocks and sand. They are able to filter away all the large particles. You get water. Okay, it's not entirely clean because the rocks won't be able to filter out the bacteria and the viruses in the water, but you get cleaner lah. You get cleaner water, and from there you can just boil it, and then you can get drinkable water. Okay. Okay, so let's look at this one. Okay, let's watch the video about filtration. Okay, this one is quite an interesting video.
Belinda, please remember to put on your apron before handling the ingredients.
Okay, Miss Zippy. Oh no! Hey, it's so clumsy. Now the beans are mixed with the salt. Sorry.
Oh my. It's okay. Now, how would you separate the beans and salt?
This is not working.
How about you, Belinda? Both your methods to separate the beans and salt are time-consuming. Can you remember any other better ways? Okay, did you notice what happens when Belinda's wet hands touch the mixture?
Hey, the salt disappeared. Oh yeah, salt is soluble in water. So when my wet hand touches the salt, it dissolves.
But the beans are not soluble and will not dissolve in water.
So if we add water to the mixture, all the salt will dissolve.
But the beans will not. Them can filter the mixture.
And separate the beans from the solution.
Let's try that out.
Stirring will help the salt to dissolve faster.
Okay, all the salt is dissolved. Now we can begin filtering it.
The filtration worked. We have the beans.
Very good. So now what do you call the beans from the filtration process?
The residue.
And the salt solution will be the filtrate.
That's right.
We managed to separate our salt and beans mixture using filtration. But our salt is still in the solution.
Oh yeah, how are we going to get back solid salt from the salt solution?
Okay, so as we can see, there's a simple method, right, filtration. So let's just review what they did. Here we have a mixture of the beans and the salt, right? Beans are insoluble in water, whereas salt is soluble in water. We then add water and stir, right? to dissolve the salt inside the solution. So you get salt solution and beans. So this is still a mixture of beans with the salt solution. And then we use a sieve, right? The sieve to filter the filtrate, which will then be the salt solution. Okay, but we'll call it as a filtrate. And we also get the residues, which will be the things that are left behind that are not able to pass through the filter. Okay, so those are called residue. In this case, it's the beans. Alright, so let's also talk about evaporation. Okay, so let's say that these two kids, right, they have the salt water and they want to get the salt back. They don't really, let's say that they don't need the water lah. Okay, let's just say for example, if they don't need the water back, they just want the salt. Then what can they do? They actually can do this thing called evaporation. Okay, what is evaporation? When you have a solute, which is a solid, and a solvent. Okay, remember what are solutes? Things like sugar and salt. These are solutes. Okay, these can actually be separated using evaporation. And so the solvent changes from a liquid to a gas at a much lower temperature than the solute. Okay, so what does it mean? It means that, for example, a liquid water, it would evaporate into a gas at maybe 100 degrees Celsius. But the solute, for example, salt, it only turns into a gas at, I think, like 1000 or even more than 1000 degrees. So it's very difficult. You can't possibly get 1000 degrees in a school lab. Okay, so that's why we can use this evaporation technique. Okay, once again, the solvent that is removed from the solute, then we leave behind the solute as a residue. Okay, let's look at the example over here. We see that salt dissolves in water to form salt solution. All of the salt solution will pass through the filter paper, right, as we saw in the video, right? Hence, salt cannot be separated from water by filtration. Evaporation has to be used instead. Okay, so the first step, of course, we apply heat. It can be from a Bunsen burner, it can be from an oven. Okay, any sort of heat, even from the sun. You can just put the sunlight right above the crucible, right? It's like something like a plate, right, with the salt solution inside. And then this will actually speed up the change of water into water vapor. Okay, so that just want to clarify 2 points here, right? There's 2 words that we use: evaporation and boiling. Okay, now remember, evaporation can occur at any temperature, right? So for example, 70 degrees, 80 degrees, it can evaporate already. But for boiling, there's a very specific temperature where the water will very quickly turn into gas. Okay, so here we are using a mixture of, like, kind of using both methods lah, right? We're using evaporation and boiling together. Okay, so what we'll see is that the water will change state, right, from a liquid turn into a gas at a low temperature as compared to the salt, which is 100 degrees lah, right? Water will turn into a water vapor at 100 degrees. And so this salt will be left behind as a residue, right? It's a solid salt now. And so we see that water has a boiling point of 100 degrees, whereas salt has a boiling point of more than 1000 degrees. Okay, for sugar, now sugar, we can't really do this same method of evaporation easily, right? Why? Because sugar, the boiling point is quite near to 100. What does that mean? That means that if you try to boil the sugar will actually turn into caramel. Okay, so that's something that we can't do this method easily for sugar. We can only do this method easily for salt. Okay, the evaporation to dryness method. Okay, so what is evaporation for, right? It's a process that's used to obtain a dissolved solid, such as solute, from a liquid, the solvent, right? An example, solute will be salt, solvent will be water. Okay, can we use it for other things? Yes, okay, but the most common one, of course, will be water and salt. Okay, so there are some applications of evaporation over here. So for example, we can have dried food products. Now, why do we dry our food products? One of the reasons is because we want to preserve it. Bacteria can grow in food that is moist or wet. If we dry it, then it's difficult for the bacteria to grow. Right, so they say that water is essential for decomposition. In order to preserve food, water is removed using evaporation. Right, this can be applied using the production of herbs, spices, blah blah blah. Okay, so all these dried food, they are actually evaporated to dryness, probably using the energy from the sunlight. And you just put it in the sun and then they just dry. Okay, one other example would be to create salt, right? We use salt every day, right? Most of us, when we eat food, we add a little bit of salt. And where do we get our salt from? We actually get it from a farm. This place is called a salt farm. It's very common in countries like Korea, China, Thailand, right? So these places, they actually provide us with salt. What do they do? Firstly, they pump in seawater, right, into this field over here, right? They just pump in seawater and then they just let the sun dry it. Okay, usually they have to find the right time in summer or when it's less rainy season, right? And then they just let it evaporate under the sun. They then collect the piles of salt and then they can sell it. Right? Usually they just clean it up a bit and then they can sell it already. Okay, so this is called a salt farm. Okay, but what if, linking back to the video that we saw about the girl and the boy, right? Imagine that the girl and the boy, they really want the water back, right? They want the beans, which was already filtered out as the residue. They want the salt, right? And they want the water. So they cannot afford to lose that water. They can't use evaporation, right? It's not that simple. They actually want to get the water back. How can they do it, right? That's where they were going to do this new technique called distillation. Okay, we'll watch the video, then I will go through the details of distillation.
We managed to separate our salt and beans mixture using filtration. But our salt is still in the solution.
Oh yeah! How are we going to get back solid salt from the salt solution?
Well, you can let the water slowly evaporate from the solution, and when it's dry, you get your salt.
That's too slow!
Yeah, we'll have to wait for days.
What's a good way to speed up evaporation then?
We can try boiling the solution. That will speed up the evaporation to dryness.
The melting point of salt is very high compared to the boiling point of water, so the salt solution can be boiled to dry it quickly.
And we will be left with the salt.
Do you know a way to try get both salt and water from salt solution?
Water vapor? Rain?
When water vapor rises, it cools down and forms tiny water droplets.
Condensation. Then the droplets gather and form bigger and bigger clouds, until the clouds are too heavy and fall as rain.
Good. Now, how would you relate the process of rain formation to your situation of getting both salt and water from salt solution?
I know! We need to first evaporate the water from the salt solution. Then the water vapor needs to be condensed to get the water.
That's right. The process is known as distillation.
And after all the water is evaporated, we're also left with a solid salt.
Exactly. Shall we go try to separate salt and water from your salt solution? Now, this is a simple distillation setup. We've put some of your salt solution into this boiling tube. Alright, so shall we begin? Okay, let's slide up the Bunsen burner. Now, observe closely what happens when the water boils.
Wow, the water is boiling!
Oh, there's condensation.
Now, can you tell me what happens during distillation?
Yes, I know! The salt solution is heated and boils. The water turns into steam and rises.
The steam travels through the delivery tube towards the test tube, which is cooled by ice water.
The colder inner surface of the delivery tube cools the steam, which condenses into water droplets.
The distilled water is collected in the test tube.
When evaporation to dryness happens, we are left with the salt.
And this whole process is called distillation.
Very good. As you can see, distillation has helped to separate the salt solution into its components. Evaporation to dryness of the water allows us to get salt, while trapping and condensing of the water vapor allows us to get pure water.
Yay! Let's repeat this with the rest of the solution.
Okay, so that was distillation, and now let's talk about what more we can learn about distillation. Okay, we know that substances that boil at different temperatures can be separated using distillation. Right, a mixture is boiled, and the substance with the lowest boiling point in the mixture changes into a vapor first. This vapor then condenses when it comes into contact with a surface of a lower temperature. The condensed vapor is collected, leaving behind the other substances in the mixture. Okay, so just now in the video, they did what you call as a simple distillation. Right, it's basically they just use a boiling tube with a simple delivery tube, right, and they get the solution. That's quite simple to do, but this will be the full, I would say the full distillation setup. Okay, so you also need to know how to do this, right, for your Sec 3 or for your Sec 4 chemistry. Okay, let's talk about what happens. There are two ways you can do about this. Okay, first let's talk about salt and water. Okay, so we know that salt has a very high melting and boiling point. So basically it's almost impossible to turn the salt into a gas lah. Okay, whereas water, it has a boiling point of 100 degrees. Right, it turns into a gas, water vapor, at 100 degrees. So what we do is that we heat up the salt solution in a distillation flask until it boils. So you see this round flask. This is actually called a distillation flask. Okay, why is it round? It's actually so that the heat can be more evenly distributed. You may also notice this thing called boiling chips. Right, these boiling chips, they actually move around and they actually prevent over bubbling. That's what is over bubbling. Okay, you know that when you boil something, there's a lot of bubbles, right? When the bubbles pop, sometimes it can actually cause liquids, right, to spurt out, and maybe spurt upwards. That's not good. You don't want that. So the boiling chips, they prevent over bubbling. They prevent the too much bubbles from forming in the solution. Okay, here we see a thermometer. Right, the thermometer is just to measure the temperature of the gas, right, of the water vapor as it is going through this setup. So what happens is that the water vapor, it boils, it turns to a gas, it goes up, I follow my mouse, goes past the thermometer will reach 100 degrees Celsius. Since there's nowhere else to go, it will go to the right, through this setup over here called a condenser. Okay, now you may recall that condensation occurs when a hotter gas, right, lands on a cool surface. Right, one example would be when you drink a Coca-Cola, right, the Coca-Cola can is cold, right, and then condensation of the gas of the water vapor around the Coca-Cola can, it can then land on the Coca-Cola can, condense, and then you get the water droplets that surround your cold Coca-Cola. Okay, in the same way, here we have actually a cold condenser. We can actually pump cold water in. Right, you see this bottom here, you see this water in. You actually pump in cold water, it fills up the entire condenser. So this condenser is a hollow tube. Okay, hold on. Okay, so the whole condenser tube gets filled up with water, with cold water, and then some of the water it's a continuous process, right? You keep on pumping in water and water keeps on going out. So there's actually two tubes, one in and one out. We actually need to put the water tube from the bottom, right? So water in goes at the bottom. This is because you'll fill up the entire condenser with water. If you put it the other way around, that means you put water in, then you just drip out in a weird way, and then the whole condenser cannot be filled up. So you must put it from the bottom. Okay, so this condenser, right? As the water changes into steam, it passes through the condenser, and the condenser has cold water running through it continuously. The steam will then cool down and it will condense into pure water, which is called the distillate. The salt presented in the salt solution remains in the distillation flask. Okay, so what we see is that the steam, right, goes through a condenser, it turns back into water, right, and then it drips out over here. We collect it in a flask and we call this as the distillate. Right? Distillate is anything that we collect through distillation. In this case, it's pure water. Right? Why is it pure? Because we have removed all of the other substances from it, and so the salt is left behind as a residue, and then the pure water becomes the distillate. Okay, please write this down. This text over here, we see that the boiling chips, as I wanted to tell you just now, the boiling chips and the distillation flask, they help to distribute the temperature and prevent over bubbling. Okay, so write that down and link it to the, I can't draw an arrow, can I? Yes, I can. Okay, this. Okay, so distribute the temperature and prevent over bubbling. Okay, so what is distillation, right? Distillation is a process that separates substances with different boiling points through boiling and condensation. Okay, so this is one example of distillation. I will now talk about the second way that distillation can be done. We said that this one was with salt and water. Okay, what if I have two liquids? For example, water and oil. Okay, they're both liquids, right? And they are gonna behave differently from this. This is a mixture, right? So how can we actually separate the oil and the water? Then this will actually occur in a quite similar way, but more interesting. Okay, so we see that, let's say that let's not use oil lah. Let's say alcohol. Okay, let's say that we have alcohol and we have water. Okay, so alcohol has a boiling point of 78. Okay, so let's see over here. Liquid X is my alcohol. It's a boiling point of 78. And my water has a boiling point of 100. Okay, and let's say I have liquid Z, which is, just call it liquid Z. Liquid Z has a boiling point of 150. Okay, what will we see if we use distillation? The first liquid to boil will be liquid X because it has the lowest boiling point. So liquid X will boil first, and then as we see, it will turn into a vapor. It will go up through the condenser, become cool down, turn into a distillate, and then you can collect liquid X, right, which is alcohol. You then just simply get a new flask, right, a second flask, and you put it underneath. Okay, now the temperature continues to increase, goes until 100 degrees Celsius. Then liquid Y, which is our water, will then start to boil, and then it will start to turn into a gas. It will be instant, right? Go up, then through the condenser, then you can collect it inside the flask, the second flask. You then remove the second flask, you put a third flask, then now you let the temperature increase even more. You let it increase temperature until 150. Then liquid Z would start to evaporate, turn into a gas, go up, right, through the thermometer, right, which will now reach 150 degrees, then go down the condenser, cool down, turn into a distillate of liquid Z. Okay, so that's how you actually can use distillation to separate three different liquids, right, with different boiling points. And so this was actually how people in India and in China, they make rice wine and beer. They use this process of distillation, right? So they're actually separating, actually what they want is the alcohol, because alcohol is, people want to drink it, right? So they actually get alcohol using the process of distillation. Here. Okay, distillation is quite similar to what you have learned in primary school about the condensation cycle, right? The water cycle, the water cycle of water lah. Okay, so we see that when the water evaporates, then it cools down in the cool clouds, right? The clouds are cooler, so there's condensation of water vapor, and then the water can then return to the ground as rain. So this is very similar to our process of distillation, right? Firstly we evaporate the water, or we boil the water, it turns into a gas, it then cools down in the condenser, and then it returns back as a pure water, or pure distillate inside the flask over here. Okay, so distillation is very useful, right? We make all kind of products with it nowadays, right? For example, perfume, right? Your Chanel No. 5, your Hugo Boss or whatever kind of thing. All these perfume, actually they have to use distillation to create the perfume. To get distilled water, now distilled water has another name, and you can just call it as pure water. Okay, distilled water is actually very clean. It means that you can drink distilled water, right? There's no harmful things inside, because the water, as we said, it has already been distilled through the distillation process, and then we get pure water. Okay, so these two words are very similar. Distilled water and pure water are very similar. Okay, you can make food flavorings, you can get drinking water or seawater. All of this is through distillation. Okay, one example in Singapore, we have this place called a desalination plant. Okay, the word saline means salt. So I say desaline means I remove the salt. Okay, so I can actually distill the seawater to allow us to get drinking water. Okay, so this is, I think there are 2 or 3 of these desalination plants in Singapore, and together, right, with the new water plant, they actually provide a lot of water for Singaporeans to drink. Okay, let's talk about these 2 learning points and then we'll wrap up today's session. Okay, so we have 3 different scenarios: water and muddy water. How will we get this? How we separate the muddy water and the water? Right? The easiest way, of course, would be to use filtration. Okay, filtration, because you can just filter out the muddy water. You don't even have to have a heat source. You don't need to, light a fire or anything. You just need to filter away the muddy water. The mud from the water. So what will be the residue in this case? The mud will be the residue, and then the water will be the filtrates. Okay, in this case of filtration. Okay, what if I have pure water and sugar solution? Okay, like I told you just now, you can use evaporation, but you cannot overboil it. Okay, because if you overboil it, the sugar will melt, it turn into caramel. So you actually have to do this thing called low temperature evaporation. You just basically let the sugar evaporate naturally, right, under the sun, or you just put it under very low heat, right, maybe 50 degrees or 60 degrees, let the water evaporate very, very slowly, then you get the sugar crystals back, right? But you cannot overheat it. If you overheat above 100 degrees, then the sugar will melt, right, turn into caramel. Okay, ion fouling for sand, obviously we know, easiest way, use magnetic attraction. Okay, now, number 2. What will you do if you are given a mixture of iron fouling, salt, and sawdust? How can we separate all of these different constituents of the mixture? Okay, so first of all, I use a magnet to remove the iron fouling. That's the easiest part. Okay, I then add water to dissolve the salt, and then I use filtration to remove the sawdust. Right, the sawdust will be the residue, and then the salt water will be the filtrate. I then evaporate the salt water, right, to obtain the salt, and then that's what I get. So I get my 3 things. I get iron fouling, I get salt, and I get sawdust. Okay, and so with that, we have covered 4 of the 5 different separation techniques. Let's do a little review of them. Okay, so in the first technique number 1, that is magnetic separation. Okay, what is magnetic separation for? Magnetic separation is used to separate magnetic substances from non-magnetic substances. In case you have not highlighted this, please highlight this entire sentence over here. Magnetic attraction is used to separate magnetic substances from non-magnetic substances. Okay, number 2, we learn about filtration. Okay, so what is filtration for? Filtration is a process of separating substances of different particle sizes. Okay, highlight this also. Filtration is a process of separating substances of different particle sizes. Then we learn about evaporation. Okay, what is evaporation for? Evaporation is the process used to obtain a dissolved solid from a liquid solvent. Okay, highlight this also. Then we learn about number 4, distillation. Okay, and distillation, already highlighted here. Distillation is a process that separates substances with different boiling points through boiling and condensation. Okay, so over here, these are the first 4 separation techniques. We will cover chromatography in the next lesson. Okay, now I look forward to seeing all of you back here. If you have not finished the SLS that I've assigned to you, please use the rest of this period to finish it up. Make sure that all the SLS is done. Alright, I don't want to see any undone things. Okay, so for example, like this, right? I can actually track and monitor. I see that about half the class has not finished this SLS lesson yet. I want you to make sure that you entirely finish every section, right? Make sure that your section, there's no yellow color thing, no I. It must be C blue, this completed blue, right? Then it's considered as complete. Right? Make sure that you type something, right? If you don't really answer the question, you must still fill in the blanks. Cannot leave any blanks. If not, you mark as undone. Okay, so I want to see everybody finish this by today. Alright? Okay, with that, see you soon Okay, hopefully I will test negative maybe soon. I don't know when, but should be soon. And then I'll be able to come back to school. Okay, see you guys. Bye bye. Oh yeah, you can press like and subscribe also if you want.